Okay, so this is problem 3.2.43, and they give us this function right here, x to the fourth minus x cubed minus 9. They ask us to use the intermediate value theorem to show that the polynomial p of x has a real zero in the interval from 2 to 3. So we're looking at this interval from 2 to 3, and then they want us to approximate the 0 to 2 decimal places. Okay, so the first thing is to use the intermediate value theorem to show that there's a 0 in this interval right here. What we need to do is actually evaluate the function at each of these values and show that we switch signs, either negative to positive or positive to negative. What that tells us is that if you think about what's happening in a graph here, if you go from negative to positive, it means that you're actually crossing the axis. And if you're crossing an axis, that means that you have a 0. So that's what the intermediate value theorem says. So first thing, let's go ahead and evaluate these. So if I plug in 2, I'm looking at this. 2 to the fourth is 16 minus 8 minus 9. So this ends up being a negative 1. And then if I evaluate p at 3, then I'm looking at 81 minus 27 minus 9, which is something, it actually doesn't even really matter what it is, as long as it's positive, and it is positive, but I'll go ahead and get a number for it. So 81 minus 27 minus the 9, so we're getting 45 here. Okay, all right, so we go from negative to positive, so there's a 0 between 2 and 3. And what they're doing on these problems is they're giving you a chart, and they're asking you to divide up a chart by tenths in order to approximate this. So 2 and then 2.1, 2.2, 2.3. Really what you can do, and you'll have to fill out their chart as they ask for pieces of it to be filled in, but you're trying to approximate the 0. So you just want to pick a few values and try and figure out, what's going on here. So for instance, if I with the signs. So if I plug in 2.1, then I'm looking at 2.1 to the fourth, 2.1 to the third, and then minus 9. So what I'm going to get here, so 2.1 to the fourth, you get 19.4481, and then 2.1 to the third, 9.261, and then minus 9. So if I do the subtraction there, then I get 1.1871. Okay, so right away, what I see is when I evaluated p of 2, I got a negative 1. When I evaluate p of 2.1, I got a positive value. So we're going from negative to positive in between 2 and 2.1. So we know that our 0 is actually between 2 and 2.1. And I should back up a second and tell you why I decided to start with 2.1 instead of, for instance, 2.9. Notice here that at p of 2, we're at negative 1. That's very close to 0. And then at p of 3, we're at 45, so that's way positive. So I'm thinking the 0 is very close to 2. This is why I started with 2.1 instead of something like 2.9. And I can see already that we've switched values. So the 0 is between 2 and 2.1. So then again, I'm just going to have it again. I'm going to try p of more paper. I'm going to try p of 2.05. They did want us to approximate this to 2 values. Okay, so if I plug this in, 2.05 to the fourth and to the third. Okay, so we get, and this is quite a long number here. I'm gonna go ahead and just approximate it, because we really need to see where we are in terms of sign. So 8.615125, and then minus 9. So if I go ahead and do that math right there, so I get something positive still. Okay. All right, so we know then that the 0 is between 2 and 2.05, but this is getting pretty close to 0. So I think I'm gonna try p of 2.04 next and see what I get. Okay. And whoops. And just doing the subtraction on the calculator. Yep, and I get something negative here. Okay, so the 0 is between 2.04 and 2.05, and they only wanted this rounded to 2 decimal places in terms of accuracy. Neither one of these is the 0. I mean, obviously, if it was the 0, then we would be ending up with the 0 here, but this guy's the closest. And so we're going to go ahead and call 2.05 the approximated 0. So that's what they were looking for in this problem. Okay. And in terms of working with their chart, you just have to fill in whatever it is that they're asking for. So if they're giving you a value of, you know, this, and they want you to find that value, then you've got to go through the calculation to plug that in, because they're doing an extensive chart that I'm not doing here. I'm basically just showing you how to use the theorem to get the value that, you know, that you need to plug in there. Okay. And that's it in this problem.